All right, so we already began talking about solving trig equations, and we talked through the basics, right? We talked through these steps here. If it's linear, isolate the trig function. What we're going to look at today are some non-linear problems where we need to set equal to 0 and factor. Remember, the only way to use the zero product property is if we factor set equal to 0. Okay? We'll also look at some problems today that we have to use some identities for. So, coming fresh off of our identities quiz, that will be helpful. But then remember, this is how we're going to present our solutions. We're going to give us the angle plus whatever the period is times n to express that solution repeating over and over and over each period. Okay, so we did 3 examples Friday. Let's go ahead and do a few more. Okay, so go ahead and write down this problem right here. All right, so first of all, I see that there's a sine squared. Then I also see that there's a cosine. So I can't really solve for sine squared, and I can't really solve for cosine of x because there's that other trig function. I also really can't factor because the trig functions are different. Okay? However, do we have an identity that involves sine squared x? Okay, what is sine squared x the same as? Almost. 1 minus cosine squared x. Okay, we can replace sine squared x with 1 minus cosine squared x. Okay, why would that be helpful? Well, now I have an equation where every single trig function is a cosine of x, as opposed to a mixture of 2 different trig functions. Okay? Now we have all the same trig function. Now I know that one's squared and one is not, but this is where our factoring abilities are going to have to come in. Okay? So when we factor trinomials, we like for them to be in order. Okay? So the first thing I want us to think about is that 2 has to be distributed through. Okay. We then like our trinomials in order where we have the cosine square, where we have the square term, then the linear term, then the constant. Okay. I also want to think ahead to where if I rearrange these, my leading coefficient is going to be negative, and I don't really like to factor when my leading coefficient is negative. So I'm going to rearrange and move everything over to the other side of the equal sign. Okay? This is going to become a positive 2 cosine squared x minus 3 cosine of x minus 2 equals 0. So I did 2 things at once. I rearranged so that we had our square term first and our constant term last. And then I moved everything over to the other side. And then I just kept it on the left side. But imagine moving everything over or multiplying by -1, okay, to where our leading coefficient is positive. Okay? Now we have a trinomial. Okay? We have a trinomial that we need to factor. And this is what we worked on Monday of last week. Okay, if it helps, if you need to come to the margin of your paper and write 2c squared minus 3c minus 2 and try to factor that and then change them to cosines, that's fine. Okay, you do what you need to do. But we know to get 2 cosine squared, we need a 2 cosine of x times a 1 cosine of x. And then we know in order to get this 2 right here, well, 1 times 2 is the only way to get 2. I mean, I guess not the only way, but that's what we think of, right? And one needs to be positive, one needs to be negative. Who maybe has an idea on how we can do that? Jacob?
Do 2 cosine x plus 1 cosine minus 2.
Okay, so here we have positive cosine. Here we would have minus 4 cosine. And so when you add those middle terms together, we would get that negative 3 cosine. Okay, I have no problem with you using the margin of your paper if you want to change it to more of a polynomial to factor and then come back and change everything to cosines. Okay, you decide what works best for you, but we have to get it factored. Okay, well now we have 2 factors that equal 0. So we know from the zero product property that each factor could be 0. Right? Okay. So let's start with this. Now we have like 2 problems in one to solve. Okay, let's start with this one over here. We could subtract over that 1 and then divide by 2. So we have the cosine of x equals negative 1/2. That's wonderful. We like that. Okay, we know that that's a unit circle value. Hey, and you all just filled out a unit circle, so it's sitting right in front of you. The cosine is equal to negative 1/2. Gracie, at what 2 places? 4 pi over 3. And?
2 pi.
Yep, and 2 pi over 3. Cosine is negative in the second and third quadrant. So these are the 2 angles where cosine's negative 1/2, and then we'll add 2 pi times the period. Alright. Our other factor gives us the cosine of x minus 2 equals 0, or the cosine of x equals 2. Where does that happen? We have some strange looks on faces. What? Okay, if that was secant, that'd be better, right? What values does cosine bounce in between? 1 and negative 1, because that's the range of cosine, right? Is 2 in between negative 1 and 1? No. The cosine of x can't equal 2 because it's outside of the range, which means there are no solutions that come out of this. Algebraically, it works, but trigonometrically, we don't have values where cosine equals 2. So that doesn't give us anything. And we only have these 2 solutions here. All right, write this problem down. Please do not start it without me. What's tempting to do to start this problem? Okay, and what are you trying to go with there?
Oh, and then you just get common denominator.
Okay. Other thoughts?
Minus.
Divide cotangent over. What were you going to say? No, say what you're going to say.
I was gonna say minus the cotangent, right? But then I realized we multiplied it.
Okay, so we have 3 different approaches here. Okay, I was hoping somebody would say, hey, let's just divide by the cotangent. Okay, we actually can't do that, and it is so tempting. Okay, what number are we not allowed to divide by? 0. Is it possible that the cotangent could equal 0 at some point? Yes, we don't know what the cotangent of x equals. If we divide by cotangent of x and it's 0, we have done something mathematically incorrect. So we cannot divide by a trig function. Okay? When we have that feeling of, oh, I really want to divide, the algebraic substitute would be, what's a way of dividing without dividing? Okay. Well, that's silly dividing, right? But that was a good answer. Okay, that's technically what I was asking for. When we factor, we're dividing out of a problem, but we're not dividing by anything. Do you see what I mean? So we can subtract this over. So, Kaden, you had a legitimate suggestion, even though you wanted to take it back. Okay? But now, since both terms have a cotangent, we can factor out a cotangent. Okay? Nathan, I want to come back to what you were suggesting. What you were suggesting wasn't a problem. It was, however, creating a lot of work up front in order to even get to a place of being able to solve. Okay? So I encourage you not to get too crazy with the identities in this section because we don't always need them. Fall on the identities when you don't have things that you can factor out or algebra that's not going to work. Okay? All right, so now we have the cotangent of x equals 0, and we have cosine squared x minus 2 equals 0. Hey, aren't you glad we didn't divide by cotangent of x? Because look, we set it equal to 0. Okay? Where is the cotangent of x equal to 0? Where is x divided by y 0? Okay, so pi over 2 and 3 pi over 2. And then like we talked about on Friday, the period for tangent and cotangent is pi. Okay. Also something that we talked about on Friday, every time you do this with a tangent or cotangent, if your answers are pi apart, are they? And your period is pi, you would only have to write one of them. All right, and then over here, cosine squared x equals 2. So the cosine of x is plus or minus, because we have to square root both sides, radical 2. When is the cosine equal to a positive or a negative radical 2? What's the approximation of radical 2? 1 point something. That is a problem, isn't it? This is still not falling in the range of cosine of x. Therefore, we get no solution out of it trigonometrically. Algebraically, it works, but there is nowhere trigonometrically where the cosine is radical 2 or negative radical 2.
So with the answers in green, if we were to put both of them, would we get back points?
You would not get dodge points. I am very flexible. They're just not going to both appear in the back of the book. Okay. Okay, we have 2 more practice problems, and then I'm going to give each pod a problem to work on and then put on the board. Okay? And so we will do 2 problems together. You'll do a problem, and then you might even get to copy down somebody else. Okay? We'll see what we have time for. Okay? So, second to last problem as a group. Here we are given a problem where once again we have a mix match of trig functions. That's not always a problem. Over here we had a mismatch of trig functions, but we were able to factor out something in common, right? Do we have anything we can factor out in common here? No, we don't, do we? Okay. So in order for us to be able to use algebra, it would probably be more helpful if we had the same trig function throughout this problem. Okay? So what could we look at changing? Which one? Secant squared x or tangent x? Secant squared x is the same as what? I think it's 1 plus tangent squared, isn't it? Right? Is that it? Yeah? Okay. Now we're all in the same family, or we're all the same trig function. So now we would be able to do some factoring. However, what does your equation need to be set equal to factor? 0. Do not factor unless that equation is set equal to 0. Well, that makes it pretty nice, doesn't it? In order to factor, we need to start with the GCF. What is the GCF here? Tangent of x. We don't even have to worry about a trinomial, because we have a GCF, and now we are good to solve each of those factors. We have the tangent of x equal to 0, and we have the tangent of x minus 1 equal to 0. The tangent of x equals 0. Reckon, where does that happen?
2 pi.
Okay. 2 pi, which is the same as 0, also at pi, right? So basically, every pi n, the tangent of x equals 0, right? 0 pi, 1 pi, 2 pi, 3 pi, 4 pi. Okay. And then the tangent of x equals 1. Tangent of x equals 1. Veronica? Pi over 4 and? Pi over 4 and 5 pi over 4. But the period is pi, and those two are pi apart, so only writing the first one would be sufficient. Okay? It's going to happen every time we have a cotangent or a tangent. But if you write both, I'm good. Okay, so the last type of problem I want to look at, and this is something that I sort of alluded to on Friday, what happens if we have some sort of change to the period of our function, okay? How is that going to affect our algebra? So what I want you to write down is this right here. This is our last problem, and then I'll give you one to solve at your table. Now, I don't think it is necessary for us to think about the change of the period in every problem that we encounter. Instead, let's just use algebra to adjust our answers. So this is what I want to have happen. Please solve it normally. Isolate the trig function, right? So if we isolate the trig function, we would add 1 and then divide by 2. Okay. That 3 is attached to the t. It can't come out. Okay, we can't just take things out of our trig function. Okay, so this 3t is our angle. Our angle is 3t. So I want to know the two angles in which the cosine is equal to 1/2. Okay. Where are the two angles that the cosine is equal to 1/2? Emma, what do we got? Cosine's 1/2 where?
Is it 6 meters?
Mm-hmm. Yep. So, 5 pi over 3. Okay. So we're gonna write pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi n. But our ultimate goal is to solve for t. So once we get these angles written, now that 3 that's attached to the t, now we can take care of it. Now we can divide both sides by 3 to where we get t equals pi over 9 plus 2 pi n over 3. And over here we can divide both sides by 3 to get t equals 5 pi over 9 plus 2 pi n over 3. We don't have to think about the change of the period. We can just use algebra, but we have to do it in the correct steps. Okay? So identify your angles plus the period n, then you can divide over that number attached.
Do you still have to write like the cosine t, or do you just write t?
You can just write t equals. Okay? First we write the angle equals whatever the angle is, and then divide that over to get t by itself.
Oh, okay. Yeah, sorry. I was thinking.
Nope. Yeah, nope, you're good. You're good. We gotta wrap our heads around it, right? Okay, so for the last 13 minutes of class, I'm gonna give you about 3 or 4 minutes to, as a pod, solve one of these problems. When you have it completed, I want you to call me over. I want to check it, and then one of you will write it on the board for everybody else to see. Okay? Everyone's gonna have a different problem, so here we go. Just pick one. Give you about 3 or 4 minutes to get through this problem. Good choice. Have me check it, and then I'll let you know if you're ready for